Welcome to yet another video on Java interview series. Whether you are looking for an Java interview or whether you are looking for a Spring Boot interview or questions, this video will be definitely helpful for you. If you are preparing for any interviews or like you are wanted to understand what kind of questions are asked in such organization. These are the questions which are asked for with one of my close associates. So I've taken the questions from them, and that was the L1 round. And this is one of the part one. I will be coming up with the part two shortly. Uh, let's look at the questions, what has been asked in it. So the very first question, what it was asked is the basics of Java. So when it comes to overall Java, right? So with the experience level what he had, so he was asked like, what is the deep copy and shallow copy in Java? Okay. So when it comes to copying any objects, okay. So these two kinds of copy are there. One is shallow and one is deep. Okay. So these are the approaches of copying an objects. So they differ in how the objects are being copied or like how they are handled, like in the references and other things. Now shallow. Let's discuss about shallow. When we talk about shallow, it's a new object which is copied basically. Let's say you have an existing object, okay, the original object. Now you will be copying that particular object, okay. So the object will be still same. The reference of that particular object will be pointing to that particular same object. So technically there will be two objects pointing to a single object. Two references basically pointed to a single object. Okay, so this will not be creating a new object of it. Okay, that is what a shallow copy is about. But when it comes to deep copy, it is something which is created as a new object. So when you have an original object, a duplicate object will be created. So the reference will not be pointing it. It will be a new entirely independent object. So what happens in shallow is that when you're trying to reference some object, right, and you're trying to refer something, right, but in this case in the deep copy you're completely creating a new object, new thing is referring to new, right, so there is nothing shared between it. Okay, so when do you use shallow is that basically it is simple when you want to share some data across different objects, right, use that. A deep copy is when you independently want some different objects to be created and it should be referenced as different, right. So they basically differ in how they are copied, how they are independently available, like what is the performance when it comes to shallow copy, right? It will be quite faster because it will be definitely referencing to that. But when it comes to deep copy, it has to create a new object, allocate a memory and all that, right? So how do we implement that particular shallow copy? That we call a clone. We have a clone method which we normally clone, so it will be referring to the same object. But deep copy is something actually we manually have to create it. Okay, I hope you're able to understand the difference between deep copy and shallow copy. What is TreeMap? Now this is one of the collections most frequently asked question. What happens is that ultimately the question interviewer might ask you about what kind of collections you must have asked, but there are some interviewers who directly ask questions like what is TreeMap. They are very quick when it comes to asking questions. They doesn't bother about coming the flow, or like they will randomly ask questions. Okay, now what is TreeMap and like how keys are stored in TreeMap, how it is sorted. There are many questions, back-to-back questions are asked by the interviews, dependent on the company you are being and the interviewer being asked about, right? So TreeMap is basically a part of java.util package. It implements the navigable map interface which extends the sorted map actually. Okay. So it is a map implementation which is using a red black tree, that is a self organized or self balanced binary tree to store an element. Now, what are the important part of tree map is that it is sorted. One of them is that it is quite sorted. So, if you take any other map, right, hash map or this one, they are not sorted. It's not. They will be stored in some uh, in a random order. It will not be stored in a sorted order. Okay, but tree map is something which will be sorted. Either in the natural order, right? And if you are using comparable or a comparator interface, it will be based on that. It will be stored up. Okay, so there will be a sorting to it. Okay, it will be applied either natural or manual. It is up to you. The red black tree. The internally it is used to maintain the sorting order of the keys. Okay, and it ensures that it is very quite efficient. Now, performance, when we try to look into it, the time complexity of basic operations like get, put, or remove is O of log n. Now, iteration, when you're trying to iterate over a map, it is also quite efficient when it comes to it. Okay. Now, let's look at how internally it stores, right? How it stores the key inside the map. So when you try to add a key value pair to a tree map, okay. So what happens is that the key is inserted into a red black tree, okay. So each node it contains when you say like the node, right, it stores as a node. Now inside that, what all things will be there? A key, right, a value, a pointer to the child node. Now the next point to the next, right. So what happens is that red black tree, it adjusts itself when you're trying to insert something, you're trying to delete something to maintain its balance. Okay. So it will the tree. So it is maintained or it is ordered in such a way that it should maintain the tree. Okay. So what happens is that the longest path to the is as twice as the longest to the shortest path. So this is how it is sorted. Okay. I mean how it is stored actually. So now we'll look into like how it is tree map is sorted. Okay. So as I mentioned, it is naturally sorted. Okay. So when you're using comparable, as we already know, it has got a compared to method, right? So it will naturally sort it. Okay. So when you're trying to put something like as in 1, 2, 3 as a key and then the value, right? So it will naturally sort it with 1, 2, and 3. Okay. So it will internally sort it naturally. But when it comes to you're trying to store something, like say you're using comparator and you want to apply a custom logic. Okay. So in comparator, we have a compare method which you are trying to compare two objects. Now, when you try to insert something, okay, which is a tree map, inside that we are trying to store something. So let's say you're putting something inside like the tree values inside a tree and value inside it. Now, what will happen? It will store in a custom descending order. If you see, so the logic is written in a descending order. So it will stored in a now, if you see the logic over here, if you see that A and B, then it is decided as B minus A. So this means that it should be ordered in the descending order. So hence, these are stored. The keys are stored in the descending order. Okay. Now there is an algorithm, TreeMap sort algorithm. So this sorting is based on the comparison. When you're trying to insert something, okay, it compares the existing keys with the key which you're trying to insert. Okay, so it will compare with the when you're trying to use the natural sorting order, it will compare with the comparative method. Okay, but when you're trying to use with the comparator, it is placed in the appropriate position in according to the comparison result. Okay, the red black tree, the algorithm, right? The structure, it adjusts itself to maintain the balance and the order of it. Okay, the when it comes to important points of sorting in a tree, right? It must be either comparable. It should be like using that. must be comparable at least. So otherwise you will get a class cast exception. So if there is no comparator is provided. So sorting happens only on the key. So there is no sorting applied on the values. Uh, in TreeMap, you are not allowed to store a key as a null. Okay, but hash map actually, if you compare it with it, are quite different. But when your comparison cannot perform someone, ultimately it throws this exception because you cannot compare null with something, right? So that's the reason, like, it is trying to compare, right? So that's the reason it is doesn't allow null. Now, when to use this sorted is that when you want some certain order that's sorted to be run, you want it quite efficient when it tries to finding elements entries in the range of the keys. Okay, and you want to navigate method. You want to go with the approach of the navigational way, right? The higher the key, the lower the key, the ceiling key, and then the floor key, right? So this is when actually you use TreeMap. Now, as we touched base the comparator and comparable already, and we have already talked in previous videos as well. So let's discuss about what is comparable and comparator, right? So basically, these are all interfaces, okay, and these are all defined by the Java, and it is basically used for implementing certain logic of sorting. Now, let's look at the differences. Now, when it comes to comparable, right? So, it's an interface which is used for defining the natural order of the object. Okay. So, it is defined in the java.lang package. It requires certain class to implement the comparative methods. Now, certain logic is hard coded within the class itself. Okay. So, it is suitable when you want to sort something on a certain natural order. So if you see the code over here, the comparable method is written over here, and you have this particular int compare method over here. So basically, what it returns. So basically, it will have three things. One is the negative, one is the neutral, that is zero, and one is the positive. Okay. So when it is negative, then the first object is the current object is less than the current which is past. Okay. Now with zero, it means that both objects are equal. Now when you use positive, it returns a positive, right? So it means that the current object is greater. Okay. Now if you see the example over here, what here we have done is that here it is implementing the comparable interface. Okay, and we pass that, and then if you see, we have implemented the overridden method of compare to method. Okay, so if you see at the very end the output, right, if you see, it is naturally sorted. If you see here, it is 1 2 and 3. Okay, so it is stored in such way. Now let's look at the comparator interface. Okay, so it is used for custom ordering of an object. Okay, the key point is, like, it is stored in the util package. Now there is a compare method which is defined for a certain defining the custom logic over here. Now it is quite external. You have to define a certain logic in the external, right? You doesn't need to modify the existing class, right? So we can define externally, and it is suitable for writing multiple, defining certain different criteria into it. Okay, so it is similar. There is a compare method. Now similarly, like, it will based on judged on the sorting based on the three values, whether it is negative, equals, or positive. Same things applies for that. Okay. Now, just for an example, if you see, this is something which is not extending or implementing that particular interface. But if you see here, we are going to write a, I mean, if you see the employee class, what I'm talking about, okay, not the custom logic we are writing. But let's say we are writing certain logic comparator, right? I mean, we are implementing. So we define certain different class of it our own, and then we implement the logic over there. So in this way, what will happen is that we will be able to apply two kind of logics based on our scenarios. Now, based on our logic, we can apply it. Now, let's say you want to sort it by the name, or let's say you sort it by the ID, right? So if you see here, these are all done with that. Okay, so these are the comparisons, like, now when to use what, actually we already discussed, but When you want a natural sorting order, we use comparable, and it has to be quite simple and certain single attribute. But when it comes to complex sorting and you need some multiple sorting, right, we use comparator. This is a quite old question, and like it has been asked still to date, and it has been one of the important questions as well. No matter like in concurrent API has been implemented and come up, but still like this is one of the important questions when it comes to Java. Fail fast and fail safe collections in Java. So with the name itself, you get to know that these collections, when you try to insert something or try to modify something, you'll fail, right? So there is nothing like it will be not failing, right? So it will be when you try to insert something, it will automatically fail, or that it will try to exception, right? Throw exception. Now, uh, this is basically the way the collection will be behaved when we try to modify something. Okay, when you try to iterating the collections, when you're trying to modify it, how it will behave is what the fail fast and fail safe, right? So there is a difference between these two. Now let's look at the fail fast. So fail fast is basically it will throw a exception, that is concurrent modification exception. When you try to iterate something, okay, and it detects some structural modification in the internal structure of that particular collection, right? So when you're trying to iterate, it will throw a concurrent modification section. Now, any change like you're adding, removing, updating, except you're just iterating, but apart from the adding, removing something, that this exception will be thrown, and then they are failing, and it will not. I mean, it throws an exception. It is immediately failing, right? So that's the reason it is called fail fast. Okay. So the examples of fail fast are array list, hash set, hash map. Okay. So how fail fast works is that it implement the mod count. There is a mod count which is there inside the collection. Okay. So whenever it keeps on tracking that particular mod count, like when it is trying to at the start it is initialized, right? And so if there is a change in that particular thing, it will automatically throw the concurrent modification exception. So that's where it detects like the mod count has changed. Okay, so in the natural ordering it is well defined and it won't change, right? So it is quite simple. Sorting logic is applied and it is associated with a single attribute. Okay, now when to use comparator is that we can use comparator is that we can use multiple logic as I mentioned, right? Now if you see here, when you're trying to let's look at the code, right? So if you see here, there is an ABC inserted inside it, and you're trying to iterate it. And let's say if you see in that way, I'm trying to add it, right? And if you see the moment we are trying to add something, right? So you got the exception here. Okay, so that's where when you're trying to iterate and modify something, right? It will throw an concurrent modification exception. Now, as this fails fast, right? So what happens is that these are all single threaded. It works in a single threaded. It can easily detect the bugs actually, but in multi-threading environment, when this particular collection is been modified, it may lead to an unpredictable result basically. Okay, so that's where actually the fail fast is about. Now, what is failsafe? Failsafe is something which where the collection will not throw any modification. Like the concurrent modification exception is not thrown. Even you're trying to modify the structure, you're trying to add something, delete something. So this is how what happens is that earlier in fail fast, it was operating on that particular collection itself. But in fail safe, what happens is that the clone is created, a snapshot of it, and then they are trying to iterate then on that particular part. So it's quite safe, and then it generally it's part of the java.util concurrent package, and then there are different implementation like copy on write array list, copy on write array set, concurrent hash map. Okay, So this is an example. If you see, again we are trying to insert it and then but it will, if you see here, there is no exception thrown over here, right? This is how it works. So uh, it does not what do you say, it's working on the snapshot, hence it is doesn't uh, impact the modification. Okay, so it is used to be in multi-threading environment as against to fail safe, fail fast. So performance wise it is quite little bit slower due to the overhead of creating a snapshot and then working on it, right? Now, when to use fail-safe and when to use fail-fast is that clearly in the single-threaded environment you use fail-fast. In a multi-threading environment you use fail-safe collection. Okay, so that's where in the difference is about. Okay, and we already discussed about what kind of implementation. Okay. This is one of the important questions when it comes to Java 8 features. So this out of 9 out of 10 out of 10, right? So 9 of them will definitely ask this question. What is flat map and map? Okay. So basically these are the intermediate operation. Okay. So these are the methods which are provided by the Stream API. So basically it's part of the Stream API, and it works on a stream, right? So ultimately the collection we convert it into a stream, then we perform this particular flat map and map. So we'll look into it, what exactly the map does, what exactly the flat map does. Okay, so map, it is used for one-to-one mapping. Basically whatever operation you're trying to perform. Okay, let's say you're performing uppercase, lowercase, you're trying to get something. Okay, so on each element it will perform that particular stream operation. It will return a stream consisting of the result. Okay, so it will convert that particular, whatever operation you are performing in that particular, right? So it will return the same structure, but it will not but it will transform the data, but it will return the same structure kind of it. Okay, now let's look at the example. If you see, we're trying to insert something here, and then we inserted three elements inside it, and then we are trying to convert that into a string, and then we does the upper case over here, and then we display. So now if you see here, we have made all this particular to an uppercase, if you see, and it is provided as a list. Okay, this is where the map comes in picture, right? So that's how. But when it comes to flat map, what exactly it is that you must have a one to many relationship or one to many mapping, right? So this is exactly similar to that. Earlier map was one to one mapping, but it comes to flat map, right? When you want to perform different, more than one operation on it, right? So it will flatten that. It will um, convert into a single stream only, right? So from the many of them, it will convert into a single stream, right? So output, what it will happen that you combine the multiple stream into a single flat one stream. So let's say you have three streams, you can convert that into a single stream. Okay, so that's where actually you can convert and transform that into each element into a multiple stream, and then you can flatten it into a single stream. Okay, so it's quite complex, I would say, when it comes to map compared to map. Okay, so that's where how let's look at the example. Similar way, we have inserted the array list and then we flat mapped it. If you see, we are inserting three array list over here. Okay, inside an array list. Okay, now we ultimately, if you see, we flat mapped it. We converted that particular internal list to a stream, and then we hand it over to the flat map. Then ultimately flat map will take care of streamlining it, the flattening it, and ultimately it will produce a single list. Okay, so multiple streams are converted into a single stream. That's where we use flat map. Now, as I mentioned, the difference is that only, right? So it will combine, right? So this is where actually we use it. Okay. Now there is a class not found exception and no class definition found exception. Now many interviewee will get confused, or he might not get the concept clearly. But if you just look at very closely, right, what exactly this class not found exception and no class definition is about, right? So it deals with loading a class, and then how they are I mean they how they differ in the circumstances, right? So first let's look at the uh, class not found exception. So with the name we can found out that it is kind of an text exception. Okay, so it is one of the text exception which has to be checked at the compile time, and when it occurs it throws an I mean throws, okay, and it applies dynamically to the loaded classes. Okay, so it when you're calling like methods like class dot for name, class loader dot load class, or find system class, but it is not able to find that particular class. So in that case, what it will that it ultimately the concept of class loader will come into picture, but ultimately when it is not able to found it with different bootstrap, other class loaders, right? So ultimately it will throw a class not found exception. Okay, so this is where the class not found exception will be thrown up. So when it is trying to load, the JVM is trying to load that particular class dynamically, right? It checks like whether the class is available or not. And if it is not available, it will throw that. Okay, so if you see here, in this particular non-existent class is not available, then it will definitely we have written a catch block over here, and ultimately it will throw this. Okay, and it is throwing here. But when it comes to no class definition found error, okay, it's little bit different, right? So it's an error, it's not an exception where you're trying to catch it, right? This is not in our case where we can handle it. It's a completely dynamic thing, and basically it is part of the like java.lang error. When it is throws, right, that error is something which is unexceptionally handled and we cannot handle it, right? But in case of the try catch, we know that it might happen that, and we can handle it. But here we have no provision. It ultimately will throw that. So ultimately, it will try to check whether the particular class is available or not. Or what happens is that that particular at the time of the compilation and the this one, that particular class which is required by this particular class is available during the compile time. But what happens when you are trying to let's say that somehow that particular class is removed from the environment or the class path. Okay, and when you're trying to run that particular class, right? So at the compile time it was able to find it, but ultimately when you're trying to run it, it is not able to find that. Okay, so in that scenario, ultimately when it is trying to run that particular class and it is not able to find that particular class in that particular location, right? So in that environment, that particular runtime environment, this particular class is not available. Hence, it's called it throws an, I mean it exception is like thrown, and it is an error, I would say, not exception. So it says that no class definition is found for that particular thing. So one is an exception and one is an error. Okay, so one dynamically when it is trying to dynamically load it, it is not able to find the class. But one, it is like it is the at the time of compile time it is successfully available, but at the time of runtime running it, it will not be available. Okay, uh, okay, so these are the differences. Okay, when it comes to class not found and class no class definition. Okay, so when it comes to loading the JDBC driver, that is not available. Let's say you have prepared a jar, right, and then the particular class is not available, it is missing somehow from that particular jar file, right? That case it will be no class definition found. Okay, hope you got this particular concept. uh, so this so as we already discussed, meant to use class I mean, when class not found exception happens and no class definition found error happens. This is one of the spring bean interview question. Uh, so in Spring Boot, uh, the interviewer might trying to trick you or ask you a question when he says that what is the difference between at the rate bean and at the rate auto while. So ultimately, internally, if you see what you're trying to do is that you're trying to create an instance of an bean, right? So you're trying to define and then map a bean, managing a bean of that particular in certain context, application context, right? But they internally are quite different, okay, and they're used in a different context, okay. So let's discuss what is exactly the bean, okay. So explicitly, when you're trying to when you have a class and you want to define a bean, right? So in a configuration class, you define that particular method. You annotate with the at the rate bean. So the scope can be uh, depend. I mean, it is depend on that part, but if you have to write certain annotations like at the rate configuration and at the rate bean have to be defined, right? At the bean level, method level, right? So ultimately it will register that particular bean and then it will be registered in that particular application context, okay. So it is a manual creation process. You're trying to manually create it, not AutoWire is something which you are automatically trying to create it, okay, the bean. Now when you're you can write certain complex logic or certain behavior, certain logic when you're trying to at the red bean, right? So define those things. So quite customization is possible. You can deal with initialization, how it will be initialized, instantiation, how the instantiation is happening, what kind of configuration, right? So initialization, everything can be done manually. So you cannot directly apply it to a fields, okay. So it has to be applied to the method level. So here is an example which I gave you. If you see here, we are creating an instance of it. Now when it comes to AutoWire, it's an it will automatically inject a particular object of that particular to that particular instance of that particular bean, okay. So you doesn't manually do that. You just automate define those particular instance over there, the variable name and the class name, and then you annotate with the AutoWire. So it will automatically create that. It can be applicable for field level, constructor level, setters, right? So this will be automatically wired over there. So what happens is it will automatically discover that particular class. It will inject that dependencies over here. Okay. So it will ultimately, when you're doing at the rate auto, it ultimately searches for that particular matching bean, and then it is created in the application context. It will inject that, okay, automatically. Okay, so it's quite flexible. So we can either use constructor based injection or setter based injection or field based injection. It completely depend on you. Okay, so that's how we create it, right? So if you see here, this is an example. So if you see, it is auto wired with the constructor based, okay. uh, So if you see here, that's what we have discussed. Different when to use it, right? So when you want to explicitly get a control of that particular object creation process, you use at the rate bean. Okay, let's say the third-party library classes, right? Where you cannot annotate using the at the rate component, right? We can use that. Okay. Now, when do you use auto-wired? So when you wanted to manage your injection process of dependency management, right? So either at the service level, controller level, or any other where you can manage this particular component, you can use this AutoWire. Okay, so this is an example of the two classes. I mean, two concepts like at the rate bean as well and at the rate component as well. Okay. This is in the context of Spring Data JPA or Hibernate, right? So basically, this is asked when the interviewers go from Java Basics, then Spring, then ultimately, after revolving around many of this particular question, it ultimately comes to the database or the Spring Data JPA part, right? So this basically questions with respect to in the context of Spring Data JPA. So what is entity and what is a table, right? It's part of the database. Uh, how you are trying to deal with an object that is getting mapped to a database. Okay, and these are the annotations which are used to make Java understand that this is an entity class, this is a table, what should be the table name and other things, right? So when you're dealing with database tables, right, we use this particular annotations. Okay, so at the rate entity, it's completely let's say you are defining a class and you are trying to map it to a certain table. So that particular class is tagged with at the rate entity. Okay, so it is going to map that particular class to that particular database table. Okay, so it will have a class level scope, right? So any class which is it is mandated to define that when you're trying to define a mapping for it. Okay, what happens is that when you try to define at the rate entity, it will try to register that particular bean over the class over. Okay, so if you're not defining any, let's say the table name is not defined. Okay, so ultimately it will take the name of that particular class name. Okay, the key points to remember is that it is this will mark that particular class as a persistent, so it will map that particular to the table. Okay, and with that particular thing you can actually with that particular at the rate entity you can define at the rate table as well. So which will you can define which kind of name you can define, and there are certain annotations at the rate id and other is used in the combination of primary key and other things, right? So that's where we use it. Now, as I mentioned, the table is used for mapping the particular table name, exact table name. We can define it over here, right? So we can define your own custom database table name. So not, let's say if you doesn't define at the rate table. So what will happen? It will take the class name of that particular thing and it will automatically create that. Okay. So earlier in the example there was no at the rate table, but if you see here there is an at the rate table over here where we define the schema and the name of that particular thing. Okay. This is where the difference is about. So entity you can define as an JPA entity, then it is used for the table. Other table is for the database table entity. Um, so there is no quite. I mean, these are the differences basically when it comes to at the rate entity and at the rate table. Okay, so I hope I was able to explain you what is at the rate entity and at the rate table. Okay. Uh, Hope this video was quite helpful to you. We'll come with the part 2 video shortly. Thank you. Thank you for